So we have another problem, and this is potential energy versus volume graph. And the statement of the problem is the internal energy and volume of an ideal gas changed in accordance with the given graph. That's right. In which of the sections 1, 2, 2, 3 and 3, 4 is the work performed by the gas is maximum? These are the processes. This is certainly an isochore, volume equals constant, and this is where temperature is constant, because you all know internal energy is a function of temperature. So this can be written as NCVT or NR by gamma minus 1T. So this is an isotherm, and this is where T is directly proportional to V. That means PV is equal to nRT. That means T equals P by nR multiplied by V. That means T is directly proportional to V, because this 1 to 2 lies on a straight line passing through the origin. And it's a straight line, so its slope must be constant. Its equation should be like y equals mx. So P by nR should be a constant. Since n and r are already constant, so P must be constant. So it's an isobar. And let's depict the whole process on the whole process on PV diagram. And I can say that 1 and 2 are at same pressure. That's right, it's an isobaric process. 1 and 2 should have the same pressure. And at 3 volume is constant. So volume is constant, but temperature is increasing. So in this case, U I represent as a V. U as represent I should think U like T, and T can be written as as this, and here V is a constant, so V should take a place here and P should be here. So since temperature is increasing from 2 to 3, temperature is increasing, that means at 3 pressure will be greater than pressure at 1 and 2, because 1 and 2 pressure is same. And in this case volume is increasing. That means what about the pressure? What about the pressure? So pressure at 4 will be also equal to pressure at 2 and pressure at 1. So pressure at 1 to 4 is going to be same, and volume increasing and pressure decreasing. So I am ready to depict the whole picture on PV diagram. And to do so, I'm going to draw a line for 1 to 2, and that will be simply like this, because pressure here is constant. 1, 2, 3. I can write it P1, P2 or P4, and then this will become 1 to 2 process on PV diagram, and the volume here was V0 and here it was 2 V0. I can see from here, and 2 to 3 process was an isochore. So, and with increase in pressure, that means 2 to 3 process will be like this. Yes, with pressure here as P3, and then the pressure decreases. The process is an isothermal process. Temperature is constant from coming from 1 to 2 and 2 to 3, and now we are moving towards 4, and process is isothermal with decrease in pressure because pressure at 1, 2 and 4 will be same. So the graph will be like this, and this is the 4, and the volume here I can see from here the volume is root 2 V naught. Here the volume is 2 root 2 V naught. So this is the PV diagram, and from 1 to 2 it is the easiest thing to find out the work done, because the question was related that in which case work performed by the gas is maximum. Yes, work is performed by the gas in going from process 1 to process 2, and this is this area, and this will be simply P1 2 V naught minus V naught, that is P1 V naught. This is the work done in process 1 to 2, and in process 2 to 3 work done is equal to 0 because isochoric process. And what about the work done from 3 to 4? We need to calculate. I don't know anything, but I can guess that simply that work done 3 to 4 is less than the area of this trapezoid. You can see here area of this trapezoid. So it is less than half P1 plus P3 multiplied by 2 root 2 V naught minus V naught. That means 2 root 2 minus 1 V naught. So work done during process 3 to 4 is less than half P1 plus P3. 2 gets cancelled out, so I will leave this thing, cancel this thing, half and 2, and this becomes simply root 2 minus 1 V naught. And now what can I do is the problem. I know 3 to 4 process is an isothermal process. That means equation for this will be PV equals constant. So I can write here P3 2 V naught is equal to, here at 0.4, at 0.4, yes, state 4, the pressure is P1, and it is equal to, the volume here is 2 root 2, 2 root 2 V naught. That means 2 P naught get cancelled out, and I can write here P3 is equal to root 2 P1. This is one also important result. So that I would like to calculate the value of this thing, P1 plus P3 multiplied by root 2 minus 1 V naught. And I need the result in terms of P1 and V naught, because work in 1, 2 is in terms of P1 and V naught, and if I can calculate this work done W3 4, which I am not calculating, but this will be smaller than this, so I can find the value of P1 plus P2 multiplied by root 2 minus 1 V naught, and you can write here P1 plus root 2 P1 P3 in place of P3, and this is root 2 minus 1 B0. So I can take the common and it will become P1 multiplied by root 2 plus 1 and divided by root 2 minus 1 V0, and this is simply P1 multiplied by 2 minus 1 V0. So W34 is less than, and it says that W34 is less than P1 V0, that means W34 is less than W12, work done in process 1 to 2. It has been proven. So the maximum gas work is in the section 1 to 2, and that's our answer. So thank you very much for watching.